Hello class, welcome to ESPY 5380, Introduction to Educational Statistics. Today we're going to discuss the statistical concept of variance, utilizing an illustrative PowerPoint. My name is Joan Brunet and I will be your instructor for this PowerPoint presentation. The objectives for this slide presentation are as follows. By the end of the slideshow, the learner should be able to, number 1, define variance. 2, discuss what variance tells you about the population. 3, describe how variance relates to the mean. 4, determine variance for a population. And finally, discuss how variance relates to standard deviation. So what is variance? From the field textbook, variance is defined as an estimate of average variability, or the spread of a set of scores. Put in another way, variance is a measure of variability in a distribution. We begin understanding variance by looking at the differences of each score from the mean of a population or distribution. So, in this slide with the example of heights, we find the mean or average to be 59.1 inches. And then we subtract the mean from each score of the distribution to obtain what we call a deviation score. You find when we sum all the deviation scores, that number will always be 0. So we square each deviation to rid the minus sign. This is the formula found on the slide as seen. This is the sum of all the deviation scores squared is called the sum of squares. This number describes the sample's variability. This slide shows the equation for determining the sum of squares in the example of the heights. In this case, the sum of squares is 1,146.89 square inches. The sum of squares is limited because it can be influenced by sample size. As the sample size increases, then the sum will also increase. So to eliminate the influence of size, the sum of squares is divided by the number within the population. This is shortened to the term mean square. So in our example with the heights, the mean square of this population is the 1,146.89 divided by 9, the number in the population, which equals 127.43 square inches. This is the true variability within the population and is called variance. If you're unable to test the entire population, researchers use data from a sample of the population. So then the sum of squares is divided by n minus 1 to determine sample variance. The formula for sample variance is shown on this slide. There are some limitations to variance. Number 1, it is calculated using the squares of the deviation of the scores. And number 2, it is generally not useful to describe in statistic terms as far as looking at variability in squared units, such as degrees squared or pounds squared. So, to bring the term back to its original units, the square root is then taken. When we take the square root of variance, this is the standard deviation of a sample or population. This is shown on the slide with our example of heights and would be reported with the mean to give both central tendency and the variability of the sample. The sample standard deviation equation is also provided on this slide. The standard deviation can be useful as it is reported with the mean to let the researcher know the average on either side of the mean, and it can also be used to compare samples with an error bar graph as shown in this slide. This concludes the presentation on variance. Variance is important as we look at a sample or a population. As you can see in the picture, you can have the same mean when comparing two groups, but there may be large numbers clustered around the mean, such as with the red figure, with very little variability, or you can have a large spread of numbers with extremes on both ends throughout the entire population, as seen with the blue figure. Variance ties very closely with standard deviation and is sometimes overlooked with research reporting. So don't forget to report variance within your sample and your statistical findings. Thank you very much for your time. I hope you've enjoyed the presentation.